All right, so I promised you we would be doing some easier things. We are going to start with Chapter 2, talking about inequalities and what they mean. I've listed here two inequalities. The first, x is greater than negative 2. The second, x is greater than or equal to negative 2. It's important to understand what these inequalities mean, that they actually represent space on a number line. So if I have this number line here, there's negative 2, negative 1, 0, and in this direction, negative 3, negative 4. My first inequality is saying that we need all values of x greater than negative 2. That means I don't get to include negative 2. To show this graphically, I put an open circle at negative 2, and I shade in the positive direction. So all the numbers that are bigger than negative 2. The difference in these two is this greater than or equal to symbol. I still put a circle at negative 2, but now I get to include negative 2. So we actually shade in that circle, and then we graph all of the numbers bigger than that. So this is the difference between saying you need to have a score higher than an 80% to get a cookie, higher than an 80% versus you need an 80% or more. Okay, that's the difference. This we don't get to include that value. This one we do get to include it. We approach solving inequalities in much the same way that we approach solving equations. We are undoing, with one very small exception. So I've listed 3 examples here. I'll start with the first one. 3x plus 16 is less than 7. So just like we do in solving regular equations, we subtract 16 from both sides. That gives us 3x is less than negative 9. And then we divide by 3 on both sides. What this means is that the values of x that will make this true are anything where x is less than negative 3. And we can demonstrate that graphically. We'll approach the next equation in the exact same way. Subtract 11 from both sides. But this time when we divide by negative 3, we have to switch the inequality symbol. So now r is less than positive 5. We have to do this because when we multiply or divide by a negative number, it changes the sign of the other number. So that's why we have to always reverse the inequality if we multiply or divide by a negative number. There's positive 5. And we need all values of r that are less. For this final one, there are a couple ways we can approach this. My advice would be to distribute these values so that you end up with 12z minus 3 is greater than 12z minus 10. I would add 3 to both sides. And then you would subtract 12z from both sides. And you get 0 is greater than negative 7. On something like this, you have to determine, is this statement true or false? Is 0 bigger than negative 7? In this case, it is. So our answer is all real numbers. Taking a look at the next one, in this case I might not distribute that negative 2. Instead, I would probably just subtract 3 from both sides. And I would divide by negative 2. So remember, doing that division means I have to flip the sign. So q minus 1 is now greater than negative 1. And then I would again add 1 to both sides. So I would get that q is greater than 0. There's 0. And I need all values greater. On this next one, I would want to distribute this negative value, so I have negative 10 plus r is less than r minus 15. If I add 10 to both sides, and then I subtract r from both sides, I get 0 is less than negative 5. This statement is not true. 0 is not less than negative 5, so we would say no real solutions.